Section 11.2, Managing User Accounts with Keycloak. In the previous section, we added user authentication to Edge service based on a login form. You tried logging in via a user account that was auto-generated in memory at startup time. That's fine for experimenting with Spring Security the first time, but it's not something you'll want to do in production. As a minimum requirement, we need persistent storage for user accounts and an option to register new users. There should be a particular focus on storing passwords using a robust encryption algorithm and preventing unauthorized access to the database. Given the criticality of such a feature, it makes sense to delegate it to a dedicated application. Keycloak, www.keycloak.org, is an open-source identity and access management solution developed and maintained by the Red Hat community. It offers a broad set of features, including single sign-on, SSO, social login, user federation, multi-factor authentication, and centralized user management. Keycloak relies on standards like OAuth 2, OpenID Connect, and SAML 2.0. For now, we'll use Keycloak to manage user accounts in Polar Bookshop. Later, I'll show you how to use its OpenID Connect and OAuth 2 features. Note: Spring Security provides all the necessary features to implement a user management service. If you'd like to learn more about this subject, you can refer to Chapters 3 and 4 of Spring Security in Action by Laurentiu Spilka, Manning 2020. You can run Keycloak locally as a standalone Java application or a container. For production, there are a few solutions for running Keycloak on Kubernetes. Keycloak also needs a relational database for persistence. It comes with an embedded H2 database, but you'll want to replace it with an external one in production. For Polar Bookshop, we'll run Keycloak locally as a Docker container, relying on the embedded H2 database. In production, we'll use PostgreSQL. This might seem to contradict the environment parity principle, but since it's a third-party application, it's not your responsibility to test its interaction with a data source. This section will guide you step-by-step through the Keycloak configuration for the Polar Bookshop use case. First, open your Polar deployment repository. Then define a new Polar Keycloak container in docker/dockercompose.yml.
Listing 11.3, Defining a Keycloak container in Docker Compose.
Note: Later I will provide you with a JSON file you can use to load the entire configuration when starting up the Keycloak container, so you won't need to be concerned about the container's persistence. You can start a Keycloak container by opening a terminal window, navigating to the folder where you keep the dockercompose.yml file, and running this command.
See this code.
Before we can start managing user accounts, we need to define a security realm. We'll do that next. Section 11.2.1, Defining a Security Realm. In Keycloak, any security aspect of an application or a system is defined in the context of a realm, a logical domain in which we apply specific security policies. By default, Keycloak comes pre-configured with a master realm, but you'll probably want to create a dedicated one for each product you build. Let's create a new Polar Bookshop realm to host any security-related aspects of the Polar Bookshop system. Make sure the Keycloak container you started earlier is still running. Then open a terminal window and enter a bash console inside the Keycloak container.
See this code?
Tip: Keycloak might take several seconds to start up. If you try to access it right after starting the container, you might get an error because it's not yet ready to accept connections. If that happens, wait a few seconds and try again. You can check the Keycloak logs with Docker logs, Polar Keycloak. After the message, "Running the server in development mode" is printed out, Keycloak is ready to be used. We'll configure Keycloak through its admin CLI, but you can achieve the same result by using the GUI available at localhost 8080. First, navigate to the folder where the Keycloak admin CLI scripts are located.
See this code.
The admin CLI is protected by the username and password we defined in Docker Compose for the Keycloak container. We'll need to start an authenticated session before running any other commands.
See this code?
Tip: You should keep the current terminal window open until you're done configuring Keycloak. If at any point the authenticated session expires, you can always start a new one by running the previous command. At this point, you can go ahead and create a new security realm where all the policies associated with Polar Bookshop will be stored.
See this code?
Section 11.2.2, Managing Users and Roles. We'll need some users to test different authentication scenarios. As anticipated in Chapter 2, Polar Bookshop has two types of users, customers and employees. Customers can browse books and purchase them. Employees can also add new books to the catalog, modify the existing ones, and delete them. To manage the different permissions associated with each type of user, let's create two roles, customer and employee. Later, you'll protect application endpoints based on those roles. It's an authorization strategy called Role-Based Access Control, RBAC. First, create the two roles in the Polar Bookshop realm from the Keycloak admin CLI console you have used so far.
See this code?
Then create two users. Isabel Dahl will be both an employee and a customer of the bookshop, username Isabel. You can create an account for her as follows.
See this code?
Then do the same for Bjorn Vinterberg, username Bjorn, a customer of the bookshop.
See this code?
In a real scenario, users would choose a password themselves and preferably enable two-factor authentication. Isabel and Bjorn are test users, so assigning an explicit password is okay. You can do that from the Keycloak admin CLI as follows.
See this code?
That's it for user management. You can get out of the bash console inside the Keycloak container with the exit command, but keep Keycloak running. Next, let's explore how we can improve the authentication strategy in Edge service.